Okay, let's dive into a foundational text on mensuration today.
Right.
We're really tackling the absolute building blocks, perimeter and area of plane figures.
The very basics.
Think of this deep dive as, well, your shortcut to understanding how these core ideas laid out right here in these pages let us measure the space around us.
Exactly. And the source material, it gets straight to the point, gives us, two simple definitions.
Okay.
Perimeter. That's the total length of the boundary of a shape.
The edge, basically.
Yeah, the edge. And area is the amount of surface inside that boundary.
Got it.
So our mission, really, is to unpack how these concepts and the formulas they give help solve, actual real-world problems.
And you might think, perimeter, area, simple enough. But the power, like this text shows, is how you apply them, combine them.
Definitely.
Let's start where the source does, rectangles. Seems basic, but it's the foundation.
It really is. Defined simply. Opposite sides are equal. All corners are right angles, 90 degrees.
Right.
And the formulas are the bedrock. Perimeter, P, is 2 times the sum of length and breadth. So P equals 2L plus B.
Okay, P equals 2L plus B.
And the area A is just length multiplied by breadth. A equals L times B.
Simple multiplication.
Yep.
But the text, it doesn't just stop at calculating P and A. It shows you how to work backwards, too.
That's key, like finding the breadth if you already know the area and the length.
Yeah, it's about rearranging those fundamental formulas, which I guess leads naturally to squares.
It does. The source calls a square a special type of rectangle where all 4 sides are equal.
Makes sense. Simpler again.
Exactly. Perimeter P is just 4 times the side length, so P equals 4L.
4 times L. Okay.
And area A is the side length squared.
Okay.
A equals L squared.
L times L. And again, you can work back from area to find the side length if needed.
Precisely.
Now, knowing the shapes is one thing, but the source makes a really critical point about scale, doesn't it? Measurement needs the right units.
Oh, absolutely. Units are crucial. Perimeter is linear, a length, so you use centimeters, meters, millimeters, things like that.
Standard length units.
But area, that's different. It's 2-dimensional, covers the surface. So you need square units, cm, m,
No.
m.
Right. Squared.
And the text gives those key conversions, like reminding us that 1 square meter is actually 10,000 square centimeters. A big jump.
It is. And this is where it gets really practical, especially for larger areas like land.
Yeah, the source introduces bigger units here. The R, which is 100 square meter.
100 square meters, okay.
And then the hectare, that's 100 airs or 10,000 square meters.
50,000, wow. It puts it into perspective with that example, finding the side of a square field that's 100 hectares.
Mm-hmm.
You solve that, and you realize the side is 1,000 meters, a whole kilometer.
Yeah, it gives you a real feel for just how vast those units are. It's not just abstract numbers.
Not at all. And what's great is how the source immediately ties these basics to practical uses.
Right away. Calculating costs, for instance. The examples show things like figuring out the cost to plow a field based on its area,
Area for plowing, okay.
or the cost of fencing it, which would depend on its perimeter.
Perimeter for fencing. Makes sense. Materials around the edge.
Exactly. And the text doesn't shy away from, the messier shapes either.
Yeah.
Not just neat squares and rectangles.
Yeah, those irregular composite figures, L shapes and things like that.
And the strategy it presents is really useful. Break the complex shape down into simpler rectangles you already know how to handle.
Okay, so divide it up.
Right. You add up the areas of those smaller rectangle parts to get the total area.
Simple addition for area, but perimeter's different for those.
Crucially different. The source is very clear. For the perimeter of a composite shape, you only add the lengths of the lines forming the outer boundary.
Ah, just the outside edge, not the lines you drew inside to divide it.
Ignore those internal lines for perimeter. It's a common mistake to include them.
Good point. It also shows how to handle shaded portions, right? Like finding the area of a path around a garden.
Yes, often by calculating a larger area, say the garden plus the path, and then subtracting the smaller area, the garden itself.
Clever. Subtraction to find the difference.
This deep dive also touches on triangles, the basic 3-sided figure.
Can't forget triangles.
The key formula the source gives is area A equals 1/2 times base times height. A equals half edge BAH.
Half base times height. Okay.
And it's careful to define the height. It has to be the perpendicular distance from a corner straight down to the opposite side, the base.
Perpendicular. Got it. And any side can be the base.
Any side could be the base, yeah, as long as the height is measured perpendicularly to that specific side.
Makes sense. And again, examples show finding area or working back to find base or height if you know the area.
Right. Standard application of the formula.
So let's pull this all together. What's the big takeaway here?
Well, understanding perimeter and area, like this text lays out, It gives you the fundamental toolkit for quantifying flat space, any flat space.
It's the foundation for figuring out materials needed for a job, estimating costs in building or land management.
Solving a surprising number of just everyday problems, really, by applying these straightforward geometric rules.
Yeah, it shows you how to look at something that seems complex, maybe an odd-shaped room or a huge field measured in hectares.
And break it down. Break it down into solvable pieces using these basic principles.
So it really empowers you to measure and manage space.
It absolutely does, which, brings us to a final thought, something for you to consider.
Okay.
How does this fundamental ability we have, the ability to measure and quantify space from tiny rooms right up to vast landscapes using concepts like hectares, how does that ability actually shape our modern understanding of value, how we allocate resources, and maybe even the very nature of how we plan our world?